at all.
Example 5.
Paul's diet. These can be hard.
Yeah.
Sorting all of this out.
Yeah, there's a lot of information here that we have to wade through, because now what's happening is they're putting it all on us now to do this linear programming process. So we have to come up with the objective function, and we have to come up with the constraints. So go ahead and just take a second maybe and read through, like pause the video, read through the problem, try to digest it, and then play it again once you've read it, and we'll talk about it.
Do you have a cheat sheet somewhere? I might get confused.
I think we can do it.
Okay.
Okay. So Paul's diet contains at least 24 units of carbohydrates and 16 units of protein.
All right.
So
we got carbs and proteins.
Yeah, we're going to have carbs and proteins.
Carbs and prots.
Okay. And so whenever it says at least, that means that we have to be greater than or equal to.
Because we could have more than that.
Yes, we could. Now, food substance A costs $1.40 per unit. Typically, our objective function, okay, when we write it, that's where the money is. Because typically, in real-world situations, what are we trying to max or minimize?
Our profit or our revenue or stuff like that.
We're trying to maximize profit and minimize our costs.
Right.
And so if you already read to the end, look, it's asking us about minimizing costs. So we know that in our objective function, we're going to have to put the money.
I want to be able to go to the grocery store and spend less than I earn.
That's a good call. That's a really good idea. So substance A costs $1.40, which means that we're going to have $1.40x, but that also tells us that this food substance A, whatever it is, that is what x is talking about. When we talk about x, we're talking about units of A.
Units of A.
Okay, and
it's probably pretty important to label that so
yes,
you don't get confused later.
It is. It really is. Because it tells us that food substance A costs $1.40 per unit, and each unit contains 3 units of carbohydrates. Well, our carb equation is this first one, so we would need to put a 3x there, and 4 units of protein. So we put that in our protein formula. Okay?
Nice.
And that's why this is confusing, because typically the information in one sentence in this problem isn't going to go left to right in your equations. It's going to go straight down. Mm-hmm. It's telling you all of this information about x.
Right.
And now our next sentence is going to tell us about y, which is units of B.
Okay, units of B.
Of
I
food
like
substance
it.
B.
Right.
It costs 0.9 per unit, so we have to add those together, right? You add costs together. And each unit contains 2 units of carbohydrates, so that's 2y in our carbohydrate formula, and 1 unit of protein, so that's 1y, or just y, in our protein.
So we want to have, for my carbs, at least 24, and for my prots, at least 16.
Right. And the reason that this is a problem is because guess what? Our food doesn't come, or whatever he says food. Your food doesn't come like you. I guess if you really tried, maybe you could eat a food with 1 unit of carbohydrate and 1 unit of protein, and then just like eat 24 of this and 16 of that.
My fried corn dog at the house, though, doesn't come that way.
No, it has carbs and proteins and among other things.
Yeah, probably some processed stuff in there. I'll be living forever.
So these are our constraints. That's what we just came up with. Is that
now we're probably going to get carbs, and we're going to get, we won't get negative
of either of those.
Of anything.
He can't throw up food substance that he hasn't eaten.
If you don't,
have to be positive.
Right. So x and y both have to be larger than 0.
Right. So now we're ready to graph. So let's get ourselves an x and a y axis. It's pretty straight. I don't know if it's
pretty straight,
perpendicular or not, but at least it's straight. Okay, so I like personally to graph using intercepts because most of the time they're really going to work out.
Especially when you're doing these.
When you're doing these, it's a good way to go. Okay, so the intercept here, if you cover up the y and you divide by 3, that gives you an intercept of 8. If you cover up the x and solve for y, that gives you 12. On this one, if I cover up y, divide by 4, and then 16. So this also tells me how big my scale needs to be. I need to be able to go up here to 16. That's my biggest number for y. And I need to be able to, I don't have to go out quite as much.
But you need
but
to
we might as well try to be kind of evenish.
Yeah. Evenish is good here. Oh, you're counting by 4s. That's a good call. I personally would have maybe tried 5s, but you know, with the whole 16
I like
situation.
to do like halves and stuff, so it really doesn't matter, you know, what you feel comfortable with is the way to go here. All right, so carbs. We have an x-intercept of 8 and a y-intercept of 12.
Connect them bad boys. Bam.
And then 4 and 16. It really worked out that I did by 4 since both of these
it
are.
did work out by 4. Did you change color?
No.
Change color.
What?
I don't know.
Here.
There you go. Yeah.
4 and then 16.
Yep. Connect
and
them
then
puppies.
Now, our solution region for this is where are we greater than on both of these? If we subtract our x's over, divide by our y's, we still have y's greater than or equal to.
So where does that happen?
So if we're above both of these lines, that's going to be this direction over here. All of this.
And this is that whole never-ending portion that we had mentioned in the previous example.
Right. This asked us for a minimum cost, but if it had asked us for a maximum, I mean, he could
spend an infinite number of
as
money.
much as you want. So this would be a case where no max exists. So now let's do the work to find these points. Like this one doesn't take much. That's 0, 16.
What do you?
I don't know.
That good save though. Good save.
And this is 8, 0.
8, 0. I was going to go the other way.
Yeah.
Man.
Okay. So in this one, we're going to have to solve these real quick to figure them out. I see a nice little elimination-y thing going on. So 3x plus 2y equals 24, and then negative 8x minus 2y equals negative 32. And, you know, if you solved these for y to graph them, you could easily put these in your calculator and solve, or do substitution. Like, the important part here is that you are
mathematically correct.
Yeah.
I personally...
mathematically?
I believe so.
Okay.
It's going to be a positive x value, so that's good. That's about right.
Okay.
I personally would solve all of these for y, so I could graph them. Mrs. Stevenson does the cover-up method.
Right. But
it takes you to the same place.
Yeah, either way works. So if x is 1.6, then 4 times 1.6 plus y equals 16.
4 times 1.6. 4 times 1.6 plus what?
You're subtracting that from 16.
Oh.
Sorry, I had kind of an issue with my equal sign. So you 4 times 1.6 subtract 9.6. So 9.6. Does that seem
and that
right?
looks about right, doesn't it? I
yeah.
mean, so
1.6 comma 9.6. So now we want to plug these 3 things in and see which one gives us our minimum cost. Typically my guess would be that one, but you never know. You
got to check them all.
So
it's usually going to be one of the corner points actually on somewhere in that first quadrant, and usually, but not always, but usually not on an axis.
Right.
So 0.9 times 16 is 14.4.
Okay, and now let's do 1.6 and 9.6.
10.88.
Okay, so that one's already smaller than our first one.
11.2.
So it does confirm the middle one here. So it asks us how many units of each should we purchase. So we should purchase 1.6 units of, and this is where it's helpful to have it labeled. We're purchasing 1.6 units of A, 9.6 units of B, right?
And that gets us the carbs and proteins we need for our specific diet.
Right, and that's a cost of 10.88.
Bingo.
And so if when we're doing these problems in this section or on the test, like this is the way we are expecting it to be done.
Right. You're gonna have some work there.
Yeah. So have we done a code word?
Code word Fruit Loops.
Code word Fruit Loops.
Oh, I could eat some Fruit Loops right now. That sounds really good.